Hello, here's a short video on understanding how to show the fraction of a fraction using these drawings that are in your Math 20 textbook. Understanding this is important to your overall understanding of fractions. The most important thing that you understand is that a fraction represents a part of a whole. So in this case, this represents 1 part out of 2 and 1 part out of 3. Now we're going to apply that to our geometric or our visual understanding. First thing to do is to look at this problem and realize that they are asking you to find a part of some fraction. So we're going to start with the 1/2. First thing I'm going to do is I'm going to cut this bar into half, and then I am simply going to highlight right here the half that we're going to cut. So you can see that we have half the bar highlighted. Now, that being done, it's now time to take that half and do the fraction. Cut it based on what you see there. And here it tells us to take 1/3 of that 1/2. So I'm going to come over to this 1/2 part right here, and I'm going to cut it into 3 pieces. Now, using the color is really helpful because you can see the original half shaded in yellow, and that original half chopped into 3 pieces, one of which I am going to shade in. Now, just as a reference, if this had said 2 out of 3, I would have shaded in 2 parts. But in this case, we're only shading in 1 part. So now it's time to look for the answer. I want to know how many parts are shaded out of the entire thing. Now, obviously, there's 1 part shaded out of the whole thing. So the answer, 1/3 of 1/2, is 1 part shaded out of something. And that's the question. The denominator, as you know, how many pieces make a whole? And the pieces have to be the same size. So 1, 2, 3 pieces over here, which means there also must be 3 pieces over here. And you can see it if we think about dividing the entire thing into 6 pieces. So this demonstrates that 1/3 of the 1/2 must be 1 out of 6. You may want to watch the video again, but now let's move on to another example. This is a similar problem asking us for 2/5 of 1/3. So this is where we're going to start. Think about the way the language tells us. Take a part of something. So let's start with the 1/3. First thing I'm going to do is I'm going to cut my whole into 3 equal pieces. Now, mine won't be exactly equal because I'm eyeballing it, but we'll do the best we can. So there are the 3 pieces. Now I'm going to highlight the 1/3 that I'm interested in. So there's the 1/3. Now, look at the problem, 2/5 of 1/3, and it tells you that I want to take this piece and cut it into how many? If you said 5, you're right. We're going to chop this into 5 pieces. Now again, I'm not going to be exact, but the important thing is that we're chopping it into 5 pieces. The next question for you to ask is, how many of those pieces am I going to shade? How many of those pieces am I going to select? If you said 2, you're right. I am interested in shading 2 of them. And so now we're interested in the answer. Two-fifths of 1/3 is. Now, two parts are shaded, and the question for you now is how many total parts will there be? Now, what we're about to do is critical for your understanding of fraction multiplication later on. You notice that there are 5 pieces here, which will be reflected here, 5 pieces here, and will also be reflected here. Meaning that there are a total of 15 parts. 2/5 of 1/3 is 2/15. At this point, you're probably saying, hey, 2 times 1 is 2, and 5 times 3 is 15. And that's absolutely right. That's called the algorithm, which you'll learn in section 2-3. Where I want you to focus right now is your geometric understanding. Because the question that's going to come in the next section is when we look at fraction multiplication and we multiply the 2 times 1 and the 5 times 3, where do you see the repeated addition? In other words, where do you see one group of 2? Where do you see 3 groups of 5? Look at the drawing for a minute. Where do you see 3 groups of 5? Your understanding of that is critical to your understanding of fraction multiplication. So let's do one more. 4/5 of 2/3. And when you, again, look at that problem and you ask yourself, which one am I going to start with? And the way it's set up with the word of tells me I'm going to take 4/5 of something. So this is my starting point. So let's start with the rectangle cut into 3 pieces. And what's different now is instead of shading 1 piece, the fraction now tells me to shade 2. So that's what we'll do. We'll shade 2 pieces here. Once the shading is done, it's now time to cut. And the fraction on the left, 4/5, tells me what to do. I'm going to cut this into 5 pieces. Now, looking at the fraction 4/5, the fifths tells you the 5 pieces. The 4 tells you what? Hopefully you answered. It tells you to shade 4 of them. So there's 1, 2, 3, 4. And then over here as well. 1, 2, 3, 4. And just like before, and just like with every fraction problem, we are interested in how many pieces are shaded in total. Answer, 8. And then, how many total pieces does it take to make a whole? If you answered 15, you're correct. And you're correct for 2 reasons. The first reason is in the box here, you see 3 groups of 5. Here's the third group. The other reason being, we know that multiplying fractions, you see a 5 times 3. Again, it's all reflected in the picture, 3 groups of 5. take some time to revisit this video. Focus, of course, on the algorithm. 4 times 2 makes 8, and 5 times 3 makes 15. But more importantly, before you start using the multiplication, it is absolutely necessary that you see where the repeated multiplication is taking place in this drawing. If you have any questions, please give your instructor a call.